The world is warming and humans are responsible. Greenhouse gases have been increasing in the atmosphere since the Industrial Revolution. This is warming the atmosphere, melting ice sheets, rising sea levels, causing more wildfires and changing many other aspects of the Earth's climate. In fact, the World Meteorological Organization have identified 54 elements of the global atmosphere, oceans, ice cover and biodiversity that need monitoring because they provide essential evidence for understanding, predicting and adapting to climate change. These are known as essential climate variables, and here are 8 examples. Levels of carbon dioxide in the atmosphere have been measured at Mauna Loa Observatory in Hawaii since 1958. The zigzag pattern is the seasonal cycle. With more vegetation in the northern hemisphere, the planet breathes in more CO2 during the northern hemisphere summer than during the winter. Meanwhile, the steep upward trend is the human contribution. Carbon dioxide is now 50% higher than it was before the Industrial Revolution. In fact, there is more carbon dioxide in the air today than there has been for at least 2 million years. Other pollutants, such as methane, nitrous oxide and chlorofluorocarbons, have also been increasing. These are all known as greenhouse gases because they trap heat in the atmosphere, and as greenhouse gas concentrations increase, the planet warms. Each greenhouse gas varies according to how potent it is and how long it remains in the atmosphere. For example, methane is much more potent than carbon dioxide, but its lifetime in the atmosphere is considerably shorter. Another greenhouse gas is water vapour. However, its increase is indirect. As the world warms, it becomes more humid with more water vapour in the atmosphere. As greenhouse gases increase in the atmosphere, the planet's temperature rises. More specifically, the global mean surface temperature of the Earth rises. This is the combined temperature of the surface of the Earth's seas and oceans, as well as the air just above land. Surface air temperature is the first thing that comes to mind when most of us think of global warming because of its significant and widespread impacts on ourselves and the natural world. A warming planet affects virtually every aspect of our lives, from the food we grow to the energy we consume to our health and well-being. Although the planet has warmed on average by just over 1 degree, the warming across the world has been uneven. Land areas are mostly warming faster than oceans, but the Arctic is the fastest warming place on Earth, up to 7 times faster than the global average.
With increasing global temperatures, we're also seeing increases in temperature extremes, with longer or more intense or more frequent heat waves observed around the world. And these can have substantial impacts on our health, our infrastructure and also the natural world around us, and in some cases can lead to an increased threat of wildfires.
Lightning is a significant cause of wildfires and, of course, fatalities on its own, as well as damage to infrastructure. Lightning is the result of energetic thunderstorms, with the most frequent lightning strikes occurring in the tropics, especially around Central America and Southeast Asia. As climate change causes a warmer global atmosphere with more water vapour, lightning becomes an increasingly important element to monitor. It also produces nitrogen oxides, which play an important role in the formation of and lifetime of greenhouse gases such as ozone and methane.
So phenology is the study of recurring events in nature and how these are influenced by weather and climate. Such events include flowering of plant species, hatching of tadpoles, or arrival of swifts in spring. Across the UK, phenological records show significant variations in animal and plant life cycles, which are often strongly related with climate changes. Plants in the UK are now growing leaves and flowering much earlier in spring than they used to, and they're also dropping their leaves later in autumn. And this is because of recent climate changes, particularly warming. These changes have resulted in a longer growing season for many plant species, which may have some benefits for agriculture or warmer loving species. However, they also bring risks, for example, from new invasive pests and pathogens, or as a result of native plant species becoming out of step with the life cycles of their pollinators. So as the world continues to warm and more climate extremes are experienced, phenological changes are likely to have major impacts on habitats, biodiversity and food security, which is going to have a big effect on us all.
Modern day versus vintage photographs of retreating glaciers can be one of the most visually striking examples of climate change and its impacts. The health of a glacier can be determined by measuring the loss or the advance of a glacier in any one year. When ice melt or evaporation exceeds snow accumulation, a glacier will retreat. Whilst meltwater from glaciers is essential in many parts of the world for maintaining a healthy supply of water, such as Nepal, too much meltwater because of global warming can pose a serious threat. As meltwater builds up in glacial lakes, dams can break and floods can occur. Conversely, retreating glaciers can eventually supply too little meltwater, leading to water shortages, and melting glaciers are a significant contributor to sea level rise. Loch Leven, Scotland's largest lowland loch, is an important site for otters and kingfishers, and it's home to more breeding ducks than anywhere else in inland Europe. It's also one of the fastest warming lakes in the world, currently warming at 3/4 of a degree per decade. Winter ice cover is becoming less common, and it's likely that summer algal blooms will become more common, with a detrimental effect on water quality and the lake's ecosystem. Throughout the world, lakes are warming faster than the Earth's atmosphere or oceans. Lakes are highly sensitive to changes in rainfall patterns as well as increased evaporation. They are also important sources for freshwater fish, drinking water, manufacturing, energy production, and crop irrigation. Climate change brings increased risks to the ecosystems, water supplies, food security, and tourism associated with many of the world's lakes. As the world warms, it becomes more humid. A warmer atmosphere has increased capacity to hold water vapour.
Excessive humidity affects humans and many other living organisms, from the swarming behaviour of insects to the increased occurrence of certain plant diseases. Heat stress in humans and animals can lead to dangerous conditions in some parts of the world, and there are concerns that some regions will become unlivable in the future. Humidity of the atmosphere near the surface also affects the rates of evaporation, with important feedback on the water cycle as well as global warming itself.
Most life on Earth wouldn't be possible without ozone in the stratosphere. It only exists in small amounts, but it plays a vital role in blocking damaging UV rays from reaching the surface of the planet 15 to 35 kilometres below.
Yet ozone in this lowest layer of the atmosphere, about 15 kilometres below, in the troposphere, is a harmful pollutant and acts as a greenhouse gas here. So tropospheric ozone is formed through complex chemical reactions involving other gases such as nitrogen oxides and methane, which are themselves detrimental to human health and can act as a greenhouse gas in the case of methane. However, throughout recent decades, tropospheric ozone levels have been increasing in the atmosphere, which is a problem as it can cause respiratory problems for humans, damage to plants and crops, and can even slowly degrade buildings and other materials.
The story of stratospheric ozone, however, is a hopeful one. In the early 1980s, scientists discovered that the ozone layer was being depleted by emissions of chlorofluorocarbons, or CFCs, a human-created family of chemicals that were mostly used in refrigerators and aerosols. A persistent ozone hole was found over the southern hemisphere. World governments came together and agreed the Montreal Protocol in 1987, an international treaty aimed at phasing out CFCs. Ever since, the ozone layer has been slowly recovering, evidence that governments throughout the globe can work together to avert environmental harm.